All right, so here's a free response question to practice with me. So in number 5, you're given a piecewise function. So the top piece is for when x is less than or equal to 0, and the bottom piece is for when x is greater than 0. And the first question is the function continuous at x equals 0? And could you justify your answer? So we want a calculus reason for this. And if I want a calculus reason for why it's continuous, I don't want to just substitute in and see that the answers are the same or not the same at 0. Instead, I want to write this as a limit. That's the calculus reason. So we're going to write down what's the limit as x approaches 0 from the left, and then that would be the top part. That's 3x squared plus 2x. And you can see from the left the answer is 0. And then I also want to write down the limit as x approaches 0 from the right. That would be the bottom piece, e to the 2x plus 2. So if I plug in 0, I get 1 plus 2 equals 3. So since the limit as x approaches 0 from the left does not equal the limit as x approaches 0 from the right, because that f of x is not continuous at x equals 0. So you're able to answer the question using calculus and write a simple statement that means you understand what you did, that you're looking at the limit from the left and right. They'd have to equal each other. Because the limits don't equal each other, f at x is not continuous at x equals 0. All right, part B. Can you take the derivative at -2 and the derivative at 3 of that function? We just have to understand the restrictions. -2, what piece does that belong to? So for the derivative at -2, we'd have to take the top piece. So first of all, let me write this down. The derivative of that function, the top piece would simply be 6x plus 2. That's when x is less than or equal to 0. And then the derivative of the bottom piece would be e to the 2x times 2. And then plus 2 is 0, and that's when x is greater than 0. So I take the derivative of each piece and say the restriction for it. Then when I take the derivative at -2, I realize that's the top piece. So you plug in -2 into the top piece and then solve it. So there's one answer. Now for the second answer, what's the derivative at 3? That's the bottom piece. So we're just going to plug 3 into the bottom piece and solve it. And so you see e to the 6 times 2, that's fine. Any of these would be good answers in terms of it. You don't have to simplify it down at all. All right, part C. It says explain why the derivative at 0 does not exist for the function. So, since f at x is not continuous at x equals 0, the derivative at x equals 0 does not exist. So you tie in what you've already done. So because the function is not continuous at x equals 0, therefore the derivative at x equals 0 does not exist. D. This one's the challenging one of the parts, but so far it's been pretty good, right? Let g be the function given by this, and then find g at 1. So if I want to find g at 1, first of all substitute in. Now, to answer this, I need to understand that because the derivative doesn't exist at 0, because it's not continuous at 0, I actually have to set this up as 2 integrations. One integration would go from -1 to 0, and then the other one would go from 0 to 1, and I'd separate it. Now think, why am I separating it into 2 integrations? And that's because at 0, it's not continuous. So there's the trick of it, if you like. Now, for this first part, you're obviously going to use the top piece. So if you integrate the top piece, or let's see if I have it over here. So the top piece, 3x squared and so on, all it is the anti-power rule. So that's x cubed. Divide by 3, the 3's would cross out. And the second would just be x squared. Again, divide by 2, and the 2's would divide out. So it's just x cubed plus x squared. And you're plugging in from -1 to 0. And then the second part, e to the 2x. So the integration of e to the 2x is e to the 2x, but it has a hook of 2, so it needs a 1/2. And then 2 is just 2x, and you're integrating that from 0 to 1. And now the last step. Oh, and it's in terms of t. See how they changed the variable? So I actually have to change this to t. Oops, this one here to t. E. And now the last step is just to substitute in. So we substitute in the greater value first. So 0 first. If I plug in 0, I get 0. Subtract. I'm going to use parentheses. And then -1, I plug in. I'm not going to simplify it. Subtract, or sorry, add in this case. Next, I'm going to plug in 1. And then subtract, I'm going to plug in 0. Recognize in this case that when you plug in 0, the answer is not 0, but 2 times 0 is. So you could leave it just like that, 1/2 to e to the 0, or just 1/2. There's no need to simplify it, so that's a good answer. So I think the challenging part here was just to remember they wanted you to integrate and recognize there was something that was discontinuous in the middle of it. So I had to create 2 integrations because of that discontinuity. Awesome job. Thank you for working with me here. Mr. G Math, over and out.